Lesson 2.2, Theoretical Probabilities. Our objective for this lesson is to be able to use the theoretical method to find the probability of an event. Okay, so let's start by defining theoretical probability. Theoretical probability is a method of calculating probability based on an assumption that outcomes are equally likely. So in the future, we will talk about other methods of calculating probability where we actually do an experiment and look at how often an event occurred. With theoretical probability, we don't need to do any experimentation. We're just making the assumption that all outcomes are going to be equally likely, and we calculate the probability of any particular event occurring using that assumption. All right, so the steps to finding probability using the theoretical method are first to count the total number of possible outcomes. So that's what we did in lesson 2.1. We counted the total number of possible outcomes for a given trial or experiment or scenario. Step 2 is then, among all the possible outcomes, to count the number of ways that the event of interest, A, can occur. So remember, there could be several different outcomes that give you the same event. And so we want to count how many outcomes give us the event that we're looking for. And then step 3, we're going to determine the probability, P of A, from this equation. The probability of an event A occurring is equal to the number of ways that A can occur divided by the total number of possible outcomes. So in order to see how this works, it's going to be helpful to run through a few examples. The first example asks us to apply the theoretical method to find the probability of the Diamondbacks winning exactly 2 games in a 3-game series. All right, so to apply the theoretical method, the assumption that we need to make is that each outcome is equally likely. That is, that it's equally likely that the Diamondbacks are going to win than that they are going to lose. Okay, so with that assumption, let's list out all the possible outcomes, and we did this in lesson 2.1. This is the example from lesson 2.1, and the possible outcomes are they could win, 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 lose, win, lose, win, lose, win, 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 lose, 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 win, lose, 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 win, or lose, lose, lose. Those are the 8 possible outcomes of this 2-game series, or this 3-game series. And what we want to know is, what is the probability that they'll win exactly 2 games? So you can see that there are 3 different outcomes that give us that event. There are 3 different outcomes where the Diamondbacks win exactly 2 of the 3 games. And so our probability, the probability of the Diamondbacks winning 2 games, let's call that event A, the probability of that event A is the number of outcomes where that event occurs, so that's 3, divided by the total number of outcomes, of possible outcomes, so 8. So the probability of the Diamondbacks winning exactly 2 games in a 3-game series is 3/8. The second example asks us to find the probability of getting exactly 1 heads if we flip a coin twice. So again, the assumption is that this is a fair coin, that is, that getting a heads or getting a tails is equally likely. So let's start by listing out all the possible outcomes. So the possible outcomes are heads, 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 tails, tails, heads, or tails, tails. So there are 4 possible outcomes. And now we're going to look at count up the possible outcomes that are going to give us the event we're looking for, which in this case is exactly 1 heads. So these 2 outcomes give us that event of exactly 1 heads. So our probability of our event, which we're calling event A, is going to be 2, the number of outcomes where that event occurs, divided by 4, which is the total number of outcomes. And we can reduce this fraction from 2/4 down to 1/2. So the probability of getting exactly 1 heads, if we flip a coin twice, is 1 in 2, or 1/2. The last example asks us to find the probability of rolling a 7 when we roll 2 6-sided dice. So let's start off by putting our probability down here. The probability of rolling a 7, so we'll just call that event A again. So the probability of rolling a 7 is going to be the number of outcomes that give us that event, rolling a 7, divided by the total number of outcomes that we would get from rolling 2 6-sided dice. So let's start by finding this number in the denominator. So we have the possible outcomes could be a 1 and a 1, or a 1 and a 2, or a 1 and a 3, 1 and a 4, 1 and a 5, or 1 and a 6. Or we could get a 2 and a 1, or a 2 and a 2, and a 2 and a 3, or a 2 and a 4, or a 2 and a 5, or a 2 and a 6. And notice that this is just going to continue. If our first die is a 3, there's 6 outcomes. And if it's a 4, there's 6 more outcomes. So this is going to be 6 times 6, which is going to give us 36 total outcomes from rolling these 2 dice. Now, it's important to note that this and this are 2 different outcomes. Rolling a 1 and then a 2 is different than rolling a 2 and a 1. And this is sometimes hard to see when we're just rolling 2 dice. And there are 2 dice out there, and you see that one's a 2 and one's a 1. That seems like the same outcome for each of these 2, but it is important that we count both of those outcomes. So it might be helpful if you imagine 2 different colored dice. So that if say the red die is a 1 and the blue die is a 2, that's going to be different than the blue die being a 1 and the red die being a 2. All right, so let me actually write out the outcomes that give us the event that we're looking for, rolling a 7, in different colors, so that we can make clear that these are all different events. So if the red die is a 1, well, then the blue die has to be a 6 in order to make in order to add up to 7. And if the blue die is a 2, then, or the red die is a 2, then the blue die has to be a 5. If the red die is a 3, then the blue die is going to be a 4. And if the red die is a 4, then the blue die is going to be a 3. If the red die is a 5, then the blue die has to be a 2. And if the red die is a 6, then the blue die has to be a 1. So we can see that that's, we've got 6 different outcomes that give us the event we're looking for, which is rolling a total of 7. So our numerator here is going to be 6. So the probability of rolling a 7 with 2 6-sided dice is going to be 6 divided by 36, or as a simplified fraction, that's going to be 1 divided by 6. So 1 out of 6 is the probability that we're going to roll a 7 when we roll 2 6-sided dice.